Okay, so in this tutorial, we will attempt to solve a circuit shown here. And so in this circuit, right, we have one current source, 3 amps, and one voltage source, 12 volts. And so basically, this question, right, is quite straightforward. As you can see, the question has already hinted us that we need to use node voltage method, shown by the black colored dots. And for simplicity's sake, I have circled out the nodes in orange boxes. Okay, so in case if you cannot see node 1, so let me circle out node 1, box out node 1. And by node voltage method, we'll require n minus m minus 1, which is 4 minus 1 minus 1, where the m is the number of voltage sources. So in this question, we are supposed to find I1, I2, I3 at node 1, the power dissipated, the power at 3 amp and 12 volt source, and the total power dissipated by circuit. Okay, so we can start by identifying or analyzing node 1. At node 1, we can see that there's a current I1, I3 and I2 entering the circuit. So that's our assumption, so we just write that down. Okay, so for currents entering the circuit, we'll just put a negative sign in front. Okay, so notice how I have written the currents I2 and I3 in the form of V3 minus V1 over R2, and that is because we simply follow the Ohm's law, because I is equals to V over R. And here we are trying to find the voltage difference, and when we can establish this voltage difference from the start voltage minus the end voltage. Okay, so particularly the start voltage is the voltage at node 3, and the end voltage is the voltage at node 1, because we are assuming how the current flow from node 3 to node 1. And because node 3 is a ground node, so node 3 has 0 volts. Okay. Another equation or another relationship that we can establish is that V2 minus V3 is 12 volts. And this is because there's a gain in the voltage source from 0 to 12 volts, because it's a 12 volts voltage source. So now we will further simplify the equation. Okay, so we can simplify by factorizing out V1, and then after that we can sub in the values, and it's just, you can see that V1 can be obtained by the division of 3 plus 12 over 5 divided by 1 over R2 plus 1 over R3, which we already have. And so we can get V1 by dividing 3 plus 12 over 5, and then further substituting the values, we'll divide by 0.3 and we'll get 18 volts. Okay, so now we will proceed to find the other currents I2 and I3. So I2 will be just the node voltage V1 minus the ground node over the resistance value R2, which is 10 ohms. So you'll get 1.8 amps. Okay, so for current I3 will be the node voltage at V1 minus node voltage V2 over R3, which will get 1.2 amps. But notice how the question is phrased differently, in which the current direction is pointing all towards node 1. But in the way that we do, we assume that the current is pointing outwards, so that means current I2 and I3 are pointing outwards, so that's why we get positive value. But just let me change that right now, so we'll get some consistency on the answer. Okay, so for the next part of the question, we'll proceed to find the power produced by the 3 amps and the 12 volt source. So to do that, we need to find the voltage across the 3 amps current source. So we take the voltage multiplied by the current, which is 3 amps, and we can find the power supplied by the 3 amps current source. So we'll just do that right now. Okay, so in order to do that, we need to find the voltage at V0, which is right to the left of R1, in which we quote how we note it. So V0 would be okay, so V0 minus 18, right, over 25 is equals to 3 amps. You get that? Because the current across the resistor R1 is 3 amps. Okay, so the node voltage V0 minus V1 over the resistance R1 should be 3 amps. Okay, so by doing that, we get the node voltage V0 to be 93 volts. So now what we can do is to find the power which is given by the current multiplied by the voltage across the current source, which is 93 volts, because the voltage difference is actually V0 minus V ground, which is 93 minus 0, so it's 93 volts, and we will get 279 watts, and it's in negative sign because the current is being supplied. If it's in positive sign, it means that the current is being dissipated. Okay, so now we want to compute the power supplied at the voltage source the voltage source, 12 volt voltage source. Okay, so we can do that by analyzing the node 2. Okay, by analyzing node 2, we can find out what's the current flowing through a 12 volt voltage source, which is IS2. So now we analyze node 2, we know that there's a current I3 flowing into node 2, I4 flowing out, and IS2 flowing in. So I3 will be negative, IS2 will be negative, and I4 will be positive. And we know that the node voltage at N2 is 12 volts, and so the current passing through resistor 4, which is I4, will be 12 over 7. Okay, so doing that and knowing the current I3, we can compute IS2 to be 0.514 amps. Okay, so now with the current through IS2 and we know the voltage is 12 volts, so we can compute the power supplied by the voltage source to be 0.514 multiplied by 12, which will give us 6.168 watts. So now we will proceed to compute the power dissipated, which is equivalent to power supplied, so which is the summation of the two current source and the voltage source, which will be 279 plus 6.168, which will give us 285.2 watts. Okay, so that's the end for this question. Thank you very much for your attention.